am Sahana, presently studying in Sri Venkateshwara College of Engineering, Department of Information Science and Engineering. And today in this video, I'll be discussing about on the topic of autoboxing in Java. And let's begin the topic. Introduction in autoboxing in Java. Autoboxing is a feature in Java that allows automatic conversion between primitive types and their corresponding wrapper objects. This feature was introduced in Java to simplify coding and improve readability. Autoboxing eliminates the need for manual conversion between primitive types and their wrapper objects. And you can see autoboxing and unboxing in Java like boolean, byte, char, float, int and short, and you can see between them autoboxing and unboxing. This is about the introduction to autoboxing in Java. And autoboxing of primitive types. Autoboxing automatically converts primitive types such as int, float or char into their corresponding wrapper classes like integer and float or character. This conversion happens implicitly without the need for explicit casting for conversion methods. For example, an int can be assigned to an integer without any explicit conversion. Autoboxing implies conversion between wrappers or primitives, and you can see the code of autoboxing. Code above works even though we are passing an int into an integer parameter and assuming return values of type integer to an int. This is about the autoboxing of primitive types. And next, unboxing of wrapper objects. Unboxing is the opposite of autoboxing, where a wrapper object is automatically converted back into its corresponding primitive type. Unboxing allows you to use wrapper objects as if they were primitive types. For example, an integer can be assigned to an int variable without any explicit conversion like boolean, char, byte, short, int, long, float and double. This is about the unboxing of wrapper object. In autoboxing and unboxing example, autoboxing in num equals to 10, integer object equals to num, and unboxing integer object equals to new integer 20 and in num equals to object. And with this this type cannot be primitive, but it is not a problem. And next, enumerations in autoboxing or unboxing. Special data type that enables for a variable to be set of predefined constants. This is about the examples of autoboxing and unboxing. And next, performance consideration. Autoboxing and unboxing can have an impact on performance due to the creation of temporary objects. Frequent autoboxing and unboxing can cause unnecessary object creation and memory allocation. It is advisable to avoid excessive autoboxing and unboxing in performance at critical sections of code. And the primitive types and wrapper classes you can see between autoboxing and unboxing like boolean, byte, char, int, float, long, short and double. Then next, autoboxing and collection framework. The framework of autoboxing you can see first that is iterable, and next collection, and from collection there are three types: list, queue and set. And from list, array list, linked list, vector, stack. And from queue, priority queue, T queue and array queue. And from set, hash set, link hash set, and next and link as set and reset. And next from set we can take interface, jars, intermediate and extends. And autoboxing and collections. Autoboxing simplifies the usage of primitive types in collections which primarily work with objects. Collections such as array list or hash map can directly store primitive types without the need for manual conversion. This improves code readability and reduces the amount of boilerplate code. This is how we framework the autoboxing and collections in Java. And next, null values and autoboxing. Autoboxing can lead to unexpected behavior when dealing with the null values. If a null value is assigned to a wrapper class, it will result in a null pointer exception when trying to unbox it. It is important to handle null values appropriately to avoid runtime errors. This is about the null values and autoboxing in Java like boolean, byte, int, jar, float, long, short, double. And next, autoboxing and method overloading. Autoboxing plays a crucial role in method overloading where methods can have different signatures based on the parameter types. Autoboxing allows methods to accept both primitive types and their corresponding wrapper classes as arguments. This simplifies method calls and enhance code flexibility. And example, we can see the example of function overloading. This is about the autoboxing and method overloading in Java. And next, autoboxing limitations. Autoboxing is limited to a specific set of primitive types and their corresponding wrapper classes. It does not work with custom classes or other non-primitive types. For custom types, manual conversion methods or constructors need to be implemented. And next, best practices for autoboxing. Use autoboxing sparingly, especially in performance critical sections of code. Be aware of potential null values when dealing with autoboxing. Avoid autoboxing when working with custom classes or non-primitive types. Performance of autoboxing. Autoboxing work well with collections. Don't use a lot of autoboxing in fast running applications like scientific calculations, games, etc. It takes too much of time. Next, use the primitive types. They are faster than the wrappers, and like don't do this at home in a faster running applications like integer a comma b, integer result equals to a plus b, unboxes a and b, executes plus boxes result. This is what you should do, like int a comma b, int result equals to a plus b, and it is a no autoboxing. This is how we performance and best practices of autoboxing to result. And benefits of autoboxing: simplifies coding by eliminating the need for manual conversion between primitive types and their wrapper classes, improves code readability and reduces the amount of boilerplate code, improves code reliability and reduces the conversion between primitive types and their wrapper classes, enhances flexibility in method overloading and usage of primitive types in collections like boolean, character, byte, short, integer, long, float, double, wrapper classes, autoboxing and unboxing in Java programming. This is how we benefits the autoboxing in Java. And drawbacks of autoboxing can have performance implications due to the creation of temporary objects. Handling null values requires careful consideration to avoid runtime errors. limited to a specific set of primitive types and their corresponding wrapper classes. And you can see the wrapper classes and primitive data types. That is how it changed, and this is how the drawbacks of autoboxing in Java. And next example code snippet of autoboxing in Java. Integer num equals to 5, that is autoboxing. Integer value equals to num, int value equals to num, that is unboxing. System point out point println value and output is 5, and you can see the code of autoboxing comes to resicle, that is class main public static void main string boxing and integer equals to 2, unboxing integer int is equals to 5 plus a. This is the code, this is how we code the autoboxing comes to resicle, an example of autoboxing. And next conclusion of autoboxing in Java. Autoboxing is a powerful feature in Java that simplifies the usage of primitive types and their wrapper classes. It improves code readability, reduces boilerplate code, and enhances flexibility in method overloading and collections. Care should be taken to handle null values and consider performance implications, and it improves code readability and a feature in Java that simplifies and enhances flexibility in method overloading and collections. Thank you everyone for watching my video, and please do like.